Hello, algebra class. This is section 9.6, and we're factoring trinomials of the type A, x squared plus bx plus c. And the special type of these ones is basically that our a term in front of our x squared is going to be greater than 0. So we're dealing with a coefficient that's greater than 1. Just regular routine, pause the video, work it out on your own, and then come back and see the solution for yourself. So our first one is 7m squared plus 6m minus 1. And the first thing that you want to do is you want to look at the two numbers. So we want to look at A and we want to look at our C. And we have 7 and 1, both of which don't have that many factors. So we have 7, which is a prime number, which is the only two factors are going to be 7 and 1. And then 1, the only factors that are going to multiply to give us 1 is 1. So our only option is 7 and 1 for this case. So what we have to do then is decide which order they're coming in. So the answer right here is 7m minus 1 times the quantity m plus 1. And that's because we want to look, what does it have to be to get us a positive 6n? So when we multiply, here's my check step down here. When I multiply this right here, I'm going to get 7m squared from my outer terms, or from my first terms, and then for my outer terms, I'm going to get 7m, and then for my inner terms, I'm going to get negative 1m, and then for my last terms, I'm going to get a negative 1. So when I combine these two like terms right here, I'm going to get a 6m. So that's where my 7m squared plus 6m minus 1 comes from. So the correct answer is this one right here. Right here we have the quantity 7m minus 1 times m plus 1. Here's example 2. We have 7x squared minus 12xy plus 5y squared. So for this one's a unique problem because we're working with two parentheses. But you want to carry around the same exact way. We want to first notice that 7 and 5 are prime, so the only factors are going to be 7 and 1 and 5 and 1. Knowing that, we have a couple of options. We have two different options. We have the combination of 7 and 1 times the quantity 1 and 5, or we have 7 and 5 times the quantity 1 and 1. So what happens is, right here where I have FOIL spelled out, this 35 is coming from our outer term. So when we do our outer terms, it's going to be the 7 times the 5, and that's where that 35 is coming from. And then when we do our inner terms, which is under the I, we're just going to get 1. So 1 and 1 is going to give us our 1. And then for the one on the bottom, our option on the bottom, when we do our outer terms, we have 7 times 1, which will be 7, and then 5 times 1, which is just going to give us 5. So we're looking for a 12 as our middle term, and hopefully you're able to see that the 35, whether we add or we subtract the 1 from 35, it's not going to give us 12. So that's not what we want to look at. If we combine 7 and 5, we're able to get 12, so that's where our 12 is coming from when we combine 7 and 5. And then down here, like I said, when we combine 35 and 1, we're going to get 36, so we know that's not right. But when we combine the 7 and the 5, we know that's correct. So therefore, my trick that I like to do is go back and look at your signs. So we know that this is positive, but this is negative, which means that a negative times a negative will give us a positive. So this one's easy. There's going to be no addition sign, so it's all going to be negative. So we have 5x minus 5y, x minus y. And we know that this is the correct order because when we have our terms set up like this, 7 and 5, like so, our 7 and then our 5, this is the result that we get. We get a combination of 12. And then, like I suggested, always go back and check using the FOIL method, and we'll get 7x squared minus 7xy minus 5xy, or yx, and then plus 5y squared. And then when we combine our like terms, just these two right here, we get the negative 12 xy, which was our original problem, so we're in the clear. 3 is 5x squared minus 9x minus 2. And go ahead and look, and 5 and 2 are both prime. So the factors that we're working with are 5 and 1 and 2 and 1. So again, we have a couple of different options. We have 5 and 2, and that's just taking this first number and this first number, okay? So we have 5 and 2 here, and 1 left over in the next one. And then our second option is 5 from here and 1 from here. And then the leftovers, which would be 1 and 2 in the second binomial. So what we want to think of almost if this is an x here, and this is an x here, and x here. So because we're trying to look for this negative 9x. So once again, we're going to do our outers and our inners to compare those two, because we don't really need our last two, because we know that those will give us the last two anyways. So 5 times 1 will give me 5, and 2 times 1 will give me 2. 5 and 2 will give me 10, but 1 and 1 will give me 1. So we're trying to look for a negative 9. Whether we add or we find the difference of 5 and 2, this combination is not going to work, because either we're going to get 7 or we're going to get 3, which neither of those are 9. So we want to be paying close attention to the 10 and 1, since if we find the difference between 10 and 1, it's going to be 9. So this is just reiterating what I just stated. If we combine 5 and 2, we'll get 7. If we find the difference, it's 3. 11 if we find the sum. If we find the difference, it's 9. So since I know what combination works, this 5x, and then we have to figure out what our sign will be, n times the 1, and then we have the binomial 1x, or just x, and the 2. So we just need to figure out the signs. So going back up here again, we have a negative and we have a negative, so which means that one's going to be negative and the other binomial is going to be a positive. So now we just need to figure out. I always go by rule of thumb. We want this one. Negative 9 is bigger, so that means that we want this negative 10, we want this 10 to be actually a negative 10. So to make this a negative 10, what I had to get the 10 in the first place, I took 5x times 2. Well, that means that if I wanted this to be negative, I would want a negative sign right here, so that it would be 5x times negative 2, which would give me a negative 10. So when I combine my like terms, it would be a positive 1 subtracted from combined with a negative 10. So I want the negative 2 to be right there. So my answer is going to be 5x plus 1 times the quantity x minus 2. And go ahead and check just to make sure you're getting the correct answer. And we'll get 5x squared minus 10x, like I said, but we get that negative 10x. And then a positive 1x and a negative 2. When we combine our like terms, we get back the original problem. So we know we're in the clear once again. 4, we have 2m squared plus 3m minus 27. And for this one, we know that 2 is going to be prime, but 27 is not prime, because the factors of 27 are 1 and 27 and 3 and 9. So unlike 2, which is a prime number, which is just 2 and 1, we're working with a couple more options this time. So go ahead and set up your table if you like to do it this way. If not, if you want to do it a different way, go ahead. But here's our options. We have an option to put the 2 as our first term and a 1 as our second term, and then 1 and 27. And that's just coming from our pairs right here. So we have our factors of the 2 are 2 and 1, and our factors that I'm focusing on just for right now are the 1 and 27. So then if that way doesn't work, the other option that we have is just to rearrange those terms. So 2 and 27 and 1 and 1. And that takes care of all the possible combinations for 2 and 1 and 1 and 27. So now we move down to 3 and 9. I could pair 2 and 3 together and 1 and 9. Or I could reverse them and do 2 and 9 and 1 and 3. So then, just like I've been trying to keep them underneath these outers and inners. When we do our outer terms, 2 times 27 will give us 54. And then 1 times 1, which is our inners, are going to just give us 1. So I would like to go down the line first. So 2 times 1 will give us 2. 27 times 1 will give me 27. 2 and 9 will give me 18. 3 and 1 will give me 3. 2 and 3 will give me 6, but 9 and 1 will give me 9. So I'm trying to find a 3. Okay, so 54 and 1, if I combined those, I'm going to get 55, and if I find the difference, I'm going to get 53. 2 and 27, if I combined them, I'll get 29. If I find the difference, I'll get 25. I just put absolute values here because we don't really care whether you're subtracting the 27 from 2 or 2 from 27. So we just wanted to look at what the number is, and that's going to be 25. So far we know that this doesn't work, this doesn't work. 18 and 3, if we add them together, we'll get 21. If we find the difference, it'll be 15. So either way, those don't work. So then that eliminates all possibilities except for the last two. So when we combine terms 6 and 9, we'll get 15. But when we find the difference, and again, there's absolute values here because we're just focusing on the difference, not the negative or positive value, but the difference is 3. So this is our winner. This is the scenario that we want for our factors. So we just go back to pair which one this came from, and right here is the order of our binomials and what they look like. So we have 2 and 9 and 1 and 3. So now we figured out our numbers and where they're supposed to be. Now we just have to figure out our signs. So right away we know that the m will go with the 2, and it will also go with this 1. And since this is a negative 27, we know that 1 will be positive and 1 will be negative. And since the bigger number, 3 right here, we want there to be leftover positive. So I like to go by rule of thumb, if we have leftover positive, we want the positive to go with the bigger number. So in this case, we're going to have the addition sign or the positive sign in front of the 9, and we're going to have the subtraction sign or the minus in front of the 3. So our answer is going to be 2m plus 9 times the quantity m minus 3. And then once again, we're just going to go ahead and double check. We're going to FOIL and get 2m squared, negative 6m, positive 9m, and then our last terms, which is negative 27. When we combine our like terms, our final answer will be 3m squared plus 2m squared plus 3m minus 27. Here is our last example for the video. We have 17p squared plus 34p minus 51. So go ahead and try this one on your own, then come back for the explanation. To start, instead of trying to find factors that multiply to give me 51 and add to give me 34, I noticed that 17 is actually a factor for both 51 and 34. So 17 times 3 will give me 51, 17 times 2 gives me 34. So what I did was I found the GCF of this trinomial, which again right here is telling me that it's 17. Once I found the GCF of the trinomial, I factored out the 17. So if you still need help with factoring, go back and see the videos from the last test. But for those of you who remember, we want to pull that 17 out. So I pulled it out, and when I take 17 right here, and I'm basically just dividing by 17 on all these terms, okay? And then whatever's left over, I write back in my trinomial. So 17 divided by 17 will leave me a p squared. 34p divided by 17 will leave me a 2p. And then negative 51 divided by 17 will give me a negative 3. So then, before I circle this as my final answer, I want to see, can I factor this anymore? And the answer is yes. I see that this out front of the p is just a 1, but we're looking for two numbers that multiply to give us a negative 3, but add and give us a positive 2. And so my only factors of 3, since it's prime, are 3 and 1. Therefore, our combination, what we want to do then is find where the signs go. So we want leftover positive, which means that we want our 3 to have the positive sign in front of it. So we're going to have p plus 3 times the quantity p minus 1, and we have the 17 still in front. So then we want to go ahead and check just to make sure that we are doing it correctly, or we did it correctly. We'll get p squared, we'll get negative p plus 3p, and then minus 3. And we still have the 17 out front, okay? And then if we distributed the 17 throughout, we will end up with the same answer up here. Because when we combine our like terms right here, we'll get a positive 2p minus 3 p squared, and then our 17 is out front. So our final answer is right here, 17 times the quantity p plus 3 times p minus 1.